What if a single set of photos could pry open 1,000 minds and make the whole world suddenly gossip about galaxies? Welcome to Unboxd Origins. I'm Howie, your resident science geek and accidental trivia sponge.
And I'm Wyatt. I ask the big questions. Sometimes philosophical, often skeptical, always curious.
Today we're digging into how did the James Webb Telescope images reignite our obsession with the cosmos? Okay, fasten your metaphorical seatbelts. The James Webb Space Telescope, JWST, was designed to be Hubble's infrared superpowered air, a 6.5-meter segmented mirror folded like origami, destined for a stable perch at the Sun-Earth L2 point where it could sit cold and steady. The project itself reads like a sci-fi logistics problem. Decades in planning, international collaboration between NASA, ESA, and CSA, a web of unglamorous engineering feats. Cryocoolers to chill instruments, microshutter arrays to parse spectra, and deployment sequences so elaborate they were practically a live teleplay. When it launched, people mostly followed the nail-biting deployment live streams. The tension of each unfolding mirror segment felt theatrical. But you could still hear the skeptics. Will the money be worth it? Will anyone outside the astronomy bubble notice? Then came the commissioning and the patience testing alignment of those 18 hexagonal mirror segments. The team focused light, tuned instruments, and constructed images not from pretty pixels, but from raw, calibrated datasets. The real fireworks started when Webb's first full-color images were released to the public, a curated packet designed to show off tapeability and inspire wonder. SMACS 0723, Webb's Deep Field, stunned because it packed thousands of faint red-shifted galaxies into a single frame. Stephan's quintet revealed tidal shocks and intergalactic drama in never-before-seen infrared detail. The Carina Nebula became a cathedral of star formation, and an exoplanet spectrum for WASP 96b showed signatures of water vapor and evidence for clouds or haze. Each image had a headline: Oldest Galaxies, Cosmic Scaffolding, Planetary Fingerprints. But what mattered more than the headlines was what people actually did when the pictures landed in their feeds. Social media acted like a giant echo chamber with a heart. NASA, ESA, and the mission scientists packaged the images with accessible explainers, beautiful color composites, and high-resolution downloads, widely released and freely available. Creators and educators immediately mined those assets. Simplified animations, 60-second explainers, memes that boiled down galaxies into relatable metaphors, and slow, reverent zoom-ins set to ambient music. Science communicators who had been cultivating audiences for years suddenly had perfect, shareable content. Meanwhile, the images themselves were visual bangers. They looked like oil paintings, but encoded real physical information. The public wasn't just gawking at beauty. They were being handed an invitation to understand. That red is longer wavelength light from ancient galaxies. That dark lane is dust-absorbing starlight. That bright knot is newborn stars. The combo of beauty, clarity, and explanation unlocked curiosity.
Aha! Here's the twist people often miss. The images didn't just show the universe. They revealed the process of science in an emotionally intelligible way. People weren't only seeing galaxies, they were seeing human expertise made visible. Those deployment videos, the tense live feeds, the behind-the-scenes engineer shots. They turned abstract, expensive instrumentation into a human story. Suddenly, a billion-dollar observatory was not a line item in a budget. It was the product of named people, late-night problem-solving, and tiny triumphs. And that made the science feel participatory, not remote.
Exactly. That humanized science angle married perfectly with timing. The first major image releases occurred when many people had spent years starved for wonder and connection. During the pandemic and its aftermath, online attention shifted to media that offered awe and meaning. Webb provided that in spades. But there's also a more technical ingredient to the Renaissance. Webb's infrared eye revealed structures hidden to visible light telescopes. Infrared pierces dust, showcasing star nurseries and the warm glow of early galaxies stretched by cosmic expansion. The visuals were not merely prettier versions of Hubble shots. They were new physics and new information. spectra from the telescope began answering substantive questions about galactic evolution and exoplanet atmospheres within weeks of release. And that scientific rapidity fueled journalists and explainers who love a concrete narrative. We asked a question, Webb gave an answer, here's why it matters. And let's not forget openness as an accelerant. The mission's approach, many key images and early release datasets were made public quickly, while some science programs do have proprietary periods, meant anyone with curiosity and a little skill could make their own Webb images. Amateur astronomers, hobbyist image processors, artists, teachers, they all remixed the data into accessible formats. That participatory ecosystem created a multiplier effect. One official image spurred dozens of educational threads, art pieces, and classroom activities, which then looped back into mainstream feeds. When celebrities and late-night hosts started sharing Webb images, they weren't just amplifying visuals. They were echoing a chorus of grassroots fascination that had grown online.
Aha! Another often overlooked lever was the aesthetic language adopted by the mission and the community. Webb images are colorized, but color here is a map, not mere decoration. The palette choices translate wavelengths into visible colors in intuitive ways. That mapping is a form of storytelling. It highlights physical contrasts, makes structures legible, and, critically, respects the public's need for an interpretive frame. In other words, color processing bridged two worlds: the cold, numerical output of detectors and the human visual system that craves contrast and pattern. That translation is an act of design as much as science, and it's a huge reason why people felt they could look at Webb photos and immediately get something important from them.
The storytelling didn't stop at visuals. The famous WSP-96b spectrum image, a graph basically, exploded because communicators made spectra into narratives. Light as a messenger with a barcode of chemicals. Kids could imagine reading the atmosphere's dinner menu. The more abstract the scientific product, spectra, redshift plots, light curves, the more creative communicators had to be, and they rose to the challenge. Furthermore, the academic community embraced outreach in a way that created sticky virality. Press conferences were staged for clarity. Scientists were coached on how to be both precise and accessible. Journalists, podcasters, and YouTubers had clear angles to explain. The result was a virtuous cycle. Good visuals made for good stories, and good stories made for more attention to the underlying science.
Aha! And let's not romanticize. Controversy helped too. Delays, cost overruns, and the threat of mirror misalignment gave the public a narrative arc of doubt, danger, and deliverance. That arc, failure could have happened, but didn't, is deeply satisfying. Humans respond to redemption stories. Webb's success felt like a communal triumph over doubt. Moreover, the mission's openness allowed people to poke at the tools. Amateur reprocessings, debates about color choices, and even playful conspiracies. All attention, even skepticism, is engagement. The telescope became a cultural object, a Rorschach test for how we relate to big science.
There were also educational ripple effects. Astronomy clubs reported upticks in membership. Classroom curricula integrated Webb images into lessons about light and scale. Art teachers used the nebulae as texture studies. The observable effect was a democratization of advanced astrophysics. You did not need a PhD to participate in conversations about star formation or galaxy evolution. You needed curiosity, a good explainer, and a visually compelling anchor. Online platforms that had previously siloed science content found cross-pollination. Art accounts posting nebula edits, coffee table photographers discussing cosmic composition, and gaming streamers sharing awe-filled reactions. The cosmos entered pop culture again, not as a backdrop for sci-fi plots, but as a tangible, shareable, meaningful thing.
Aha! Here's a bite-sized philosophical kicker. What Webb reignited was not just curiosity about distant objects, it revived an existential habit. looking upward and asking, where do we fit? In an age of information overload, those images offered a focal point for collective wonder. That matters because wonder is the fuel for public support of science. When people feel connected to a scientific endeavor on an emotional level, they're more likely to demand continued investment, to encourage young people into STEM, and to expect transparent, high-quality public science. Webb's images were thus both the spark and the social glue.
So what does this all add up to? Practically, it means a measurable cultural pivot. Astrophysics moved from niche fascination to mainstream water cooler topic. The excitement helped bring funding conversations, education initiatives, and public engagement strategies into sharper focus. It also created a model for future missions. Design excellent visuals, pair them with accessible narratives, maintain open data policies where possible, and create behind-the-scenes human stories. Webb proved that when you combine cutting-edge capability with smart communication and real accessibility, you can transform esoteric science into shared culture.
And on a deeper level, Webb's success is a reminder that science and storytelling are partners. A telescope is a tool, but an image is a story's first page. When that page is both true and beautiful, it invites more readers. Igniting public curiosity around the cosmos isn't just an exercise in PR. It's democratic science in action. The public becomes co-curator of the narrative of discovery.
So why it matters, the James Webb Telescope images reignited our planetary scale fascination with the cosmos by combining breathtaking new data, transparent access, humanized storytelling, and a moment in time when an audience craved awe. The result was not just viral content, but a renewed public appetite for asking the big questions and supporting the machinery that answers them.
And why that matters? Wonder leads to investment, and investment leads to more discoveries, which inspire more wonder. It's a self-perpetuating loop that enriches public knowledge, fuels the next generation of scientists and artists, and reshapes how society values big, collaborative endeavors.
If you like this dive into Webb's cultural supernova, like, subscribe, and share so more folks get curious about the cosmos.
So back to our opening thought. What if a set of pictures could make the world start gossiping about galaxies? Webb proved it could. And the gossip just might help us learn a lot more about where we come from.